So welcome to the learning series. We're continuing on looking at the new exam questions for the basic exam, which became effective July 15th, 2025. Today we're going to cover two sections, 6.1 to 6.6, and then the rest after that. So 6.1 to 6.6 is about feed lines and transmission lines. When you look at this information, the actual exam question is on the left-hand side. The material is on summary is on the right-hand side, and any sort of new question is highlighted in bold. What's different about the exam is that there are study aids and exam aids that you can bring in to the exam. So if you look here, this is, for example, the study aid, and the first five questions all have to do with frequency and with antennas. So it would be useful if you know these formulas. Well, you can bring the sheet in. So your study aid will tell you what the formula is, and then the aid you can bring into the exam. So this is the study aid, and it's all labeled, for example, here too. But when you bring it, the reference material, which will be provided in the exam, it doesn't give you the words. So it'll give you the same diagrams, but no words. So we're almost done. So we'll do propagation next week and then interference the following week. So this week we're doing section 6, feed lines and antennas. So 1 to 6 covers feed lines, and 7 to 13 covers antennas. So today we're going to talk about feed line imbalances, balanced and unbalanced RF connectors, line losses, SWR, and impedance matching. So here are some of the questions. What connects your transceiver to your antenna? And the correct answer would be transmission line C. The characteristic impedance of a transmission line is determined by, so that is determined by D, the physical dimensions and relative positions of the conductors. So every transmission line has a characteristic impedance. The characteristic impedance of a 20-meter piece of transmission line is 52 ohms. What is the impedance if 10 meters were cut off? So with the characteristic impedance of a transmission line, it doesn't change with distance. So A is the correct answer, 52 ohms. Why can coaxial cables of different diameters have the same characteristic impedance? Again, it's all related to the ratio of the conductor diameters in the coax cable. So C is the correct answer. Their characteristic impedance depends on the ratio of conductor diameters. What commonly available transmission line can be buried directly in the ground for some distance without adverse effects? And here are the 4 different types of transmission lines that we use in amateur radio. But C, the coaxial cable, can be buried without adverse effects. So C is the correct answer. A transmitter is delivering radio frequency RF energy into a coaxial cable with a characteristic impedance of 50 ohms. The cable is terminated with a purely resistive load. What value of load resistance will absorb all the RF energy if it receives? So in this case, it's 50 ohms. So you have the impedance is 50 ohms, so the load has to be 50 ohms to have a purely resistive match. So B is the correct answer. Here is a new question. What is the major factor influencing the velocity factor of a coaxial cable? So because it's a cable and it's a coax cable, things travel down the coax cable slower than the speed of light. So that's influenced by the dielectric material that's used. So D is the correct answer. Here are some more questions. The characteristic impedance of an open wire transmission line depends in part on the diameter of its conductors. What other characteristic determines the characteristic impedance? So for it's with an open ladder line or a window line, it's the spacing between the conductors. So A is the correct answer. A transmission line is terminated by an impedance that differs significantly from the characteristic impedance of the line. What impedance will be measured at the input of the line? So in this case, because you have an impedance mismatch, the impedance you measure at the other end is influenced by the line lengths. So C is the correct answer. What factors determine the characteristic impedance of an open wire transmission line? So this is similar to the previous question. So it's the distance between the centers of the conductors and the diameters of the conductors. What factors determine the characteristic impedance of a coaxial transmission line? So that's the other type. So that would be the ratio of the diameter of the outer shield to the diameter of the inner conductor. So A is the correct answer. Now we get into balanced and unbalanced systems. So what kind of transmission line has a center wire inside an insulating material, which is covered by a metal shield or sleeve? So that would be a coaxial cable. So C is the correct answer. A new question. What kind of transmission line has two wires side by side embedded in insulating material? So that would be D. That would be known as a window line. What kind of transmission line is made up of two conductors held apart by insulated rods? So in this case, that would be C, an open wire line. What is the purpose of a balun? So it's used to connect a balanced BAL to an unbalanced system. So A is the correct answer. Connects a balanced and an unbalanced system. What would you install? Where would you install a balun to feed a dipole antenna with a 50 ohm coaxial cable? So in that case here, you want to install the balun between the coaxial cable and the antenna. So D is the correct answer. A new question. What causes a transmission line to be unbalanced? So in this case here, the answer would be C. One conductor is connected to ground, and that's usually the shielded material. The shield of the coax cable is connected to ground, so it makes it an unbalanced system. What device can be installed to feed an unbalanced antenna with a balanced transmission line? And again, here it would be a balun. D is the correct answer. A new question. What device should you use to connect a coaxial cable to a window line? So here again, you're going to have a mismatch in impedances between these two transmission lines. So what you would want to do here is connect it with a balun. A balanced transmission line is made up of two parallel wires. So C is the correct answer. A new question. Your antenna tuner does not have a balanced output and you wish to use window line to feed an HF antenna. What device should you use between the tuner and the transmission line? So again, here, what you want to do is a balun, because you're going from a balanced system to an unbalanced system. Another question. What kind of transmission line has two conductors maintained side by side, a constant distance apart, using insulated spreaders? So in this case, this would be an open wire line, so A would be the correct answer. Now we get into the third section on RF connectors. A transmission line must be supported for several meters by attaching it to a metal fence. What kind of transmission line will not adversely be affected by the proximity to the fence? So in this case, if you're close to some metal object, you want to use a coaxial line, a coaxial cable. So D is the correct answer. The others may be affected by the metal object or the metal fence. A new question here. A common mode current joke can be made by winding coaxial cable on a ferrite toroid. Why is cable with a solid dielectric preferred over a foam dielectric? So in this case, the correct answer is D. There's less risk of a short circuit due to the center conductor movement. So the center conductor is more rigid in a solid dielectric than a foam dielectric. And because you're making small turns over a toroid, a ferrite material, the solid dielectric is better. Another new question. Why do most amateur radio systems use coaxial cable rather than other type of transmission line? And that's because B, more usable in a wide variety of settings. So B is the correct answer. So now we're getting into some different connectors. What type of connector is commonly installed on RJ213 coaxial cable for connection to an HF transceiver? So here you're going to have a PL259 connector. So this is the one that's on your transceiver. Now, on the other hand, if you have a handheld transceiver, you're going to be using a much smaller connector, and that is usually an SMA connector. So A is the correct answer. A new question. What popular RF connector is designed to be moisture resistant? So the only connector that is moisture resistant is an N-type connector. So A is the correct answer, although it's not used that often in amateur radio equipment, more for commercial equipment. What type of, here's another new question. What type of RF connector is commonly used for low power transceivers and test instruments? So in that case, that would be C, BNC connector. So BNC connector you find on things like oscilloscopes and signal generators and things like that. Why should you regularly clean and tighten all antenna connectors? A, to help keep their contact resistant to a minimum. And one of the things you want to be careful is not to over tighten the connectors. And if you're really concerned about it, you can actually buy torque wrenches for the various RF connectors, but they're quite expensive. Another new question. What type of coaxial outer conductor offers the best shielding? So here you can have a number of different choices, a single braided, a double braided, or aluminum foil, but a solid shield is the best shielding, so D is the correct answer. If your location is frequently affected by icy conditions, what type of transmission line would be most suitable? So in this case, you would use coaxial cable. A is the correct one. A new question. What is the primary advantage of using a coaxial cable with a foam dielectric instead of a solid dielectric? So, um, uh, a foam dielectric has lower loss than a solid dielectric, so B is the correct answer. Now we get into the section on line losses. So what is the major adverse consequence of using RG58 coaxial cable for a transmission line operating at 70 centimeters. So you're putting high frequency signals through a VHF through a coaxial cable that's relatively small. So you're going to have a lot of RF loss in this particular cable. So C is the correct answer, excessive RF loss in the transmission line. Here is a new question. What is the major advantage of an open wire transmission line? So A is the correct answer. It can be operated at high SWR without excessive losses. So A is the correct answer. And that's why some people use open wire line, because you have to worry less about SWR with an open wire line. So if your transmitter and antenna are 15 meters apart, and you are connected by 60 meters of RG58 coaxial cable, what would be done to reduce the transmission losses? So, what you want to do is to use the shortest possible piece of coaxial cable that you can. So if you're only 15 meters away, why use 60 meters? Because you'll have more loss. So B is the correct answer. As the length of transmission line is changed, what happens to signal loss? So B is the correct answer. Signal loss increases as the length increases on the coaxial cable. As the frequency of a signal is changed, what happens to the signal loss in a transmission line? So also as the signal goes up in frequency, the signal loss goes up. So B is the correct answer. Signal loss increases with increasing frequency. Assuming the same transmitter and RF output power are used, what is the effect of changing the transmission line from RG213 coaxial cable to RG58? So in this case, our RG213 is a bigger cable, and then RG58. So it's going to affect power. So the correct answer is C. Less RF power is radiated from the antenna because you're having more attenuation through the RG58 than the RG213. What is the lowest loss line on HF is? So in this case, it would be open wire line would have the lowest loss. So C would be the correct answer. In what values are RF transmission line losses expressed? And in this case, it would be decibel per unit length. So if you look at the specifications of a coaxial cable, this is what you would see. This is how it would be mentioned, listed, decibel per unit length. If the length of a coaxial cable line is increased from 20 meters to 40 meters, how would this affect the line loss? So here you're doubling the length, so you're increasing your line loss by 100%. So A is the correct answer. It would be increased by 100%. If operating frequency is increased, how does transmission line loss change? This is similar to another question. So, the line loss increases as frequency goes up, and this is due to internal line losses. Now we get into the section of SWR. So what does an SWR reading of 1-to-1 mean? So that means that you have the best impedance match has been obtained. So 1-to-1 is the best impedance match. So if you're getting an impedance match of 1.5-to-1, what does that mean? Well, some people are worried about it, but it's still a fairly good impedance match. So A is the correct answer. What is the most likely cause of erratic readings on an SWR meter? So that's most likely some form of intermittent connection. So A would be so you have an intermittent connection somewhere on the antenna system. So Which of the following can cause high SWR reading? So in this case, if you're getting something high, it can be an open or short circuit in the antenna system. And you should go investigate and correct it. Here's a new question. What is the main adverse effect due to operating at high SWR? So as you operate at higher and higher SWR, you increase transmission loss. So C is the correct answer, although it's not as bad as people claim it is. Another new question. What instrument is useful for adjusting the physical length of an antenna? So in this case, you would use an antenna analyzer and it would measure SWR versus frequency, and then you could adjust the antenna length to reduce the SWR value. So that's an antenna analyzer. If the characteristic impedance of a transmission line does not match the antenna input impedance, then what happens is you start producing standing waves. And so D is the correct answer. The standing waves are produced in the transmission line, and then the standing waves give you an SWR. The result of the presence of standing waves on a transmission line is B, reduced transfer of RF energy to the antenna. Here's a new question. What does an SWR meter measure to determine the SWR? So what you do here, what you measure here is the forward and reflected voltage in your transmission line, and if you take the ratio of that, that will give you your SWR value. What information can be obtained from an antenna analyzer? Similar to a previous question, this is also a new question. Is A SWR of the antenna system over a range of frequencies? Another new question. What is the effect of line loss on SWR reading at a station? So it decreases the SWR because reflected energy is attenuated. So if you have a very long transmission line, you'll actually be reading a low SWR, but that may not be a true reading because your reflected energy is attenuated and doesn't make it back to the meter to be read. Now we get into this whole section of impedance matching. And here's a new question. Which of the following antenna system conditions will cause a modern solid-state HF transceiver to automatically reduce power? So if with solid state transceivers, if there's a big mismatch in the impedance, then it'll cut back the power to match, so it doesn't damage the solid state. So C is the correct answer. Excessive impedance mismatch between the transceiver and the transmission line. What does an antenna tuner do? So it matches the transceiver to the mismatched antenna system. So C is the correct answer. So it adds either reactants, inductive reactants or capacitive reactants to the system to provide a better match. A new question here. An end-fed half-wave antenna has a very high feed point impedance. What device could be used to provide a good match with a 50 ohm coaxial cable? So when you look at all of these here, you would use some sort of transformer to match. So you would use an anon. So that would be A would be the correct answer. If both source and load impedance are purely resistive, what value of load impedance will result in the maximum power delivery to the load? So this is when the load impedance is equal to the source impedance, you get maximum power transfer. So A is the correct answer. Another new question. What is the advantage of locating an antenna tuner near the antenna feed point over locating it near the transceiver? So that would be B. You would have less transmission line losses because the antenna tuner is just looking at the antenna, not looking at the transmission line plus the antenna. So B is the correct answer. Another new question. How does an antenna tuner compensate for an impedance mismatch in an antenna system? So as I mentioned before, B is the correct answer. It adds capacitive or inductive reactance to the system to establish a better matching. Another new question. What advantage does a transformer present when used for impedance matching at radio frequencies? So, so this would be a transformer, so it can be used for designed for wide bandwidth. So C would be the correct answer. Another new question. What does impedance matching need to be done to minimize transmission line losses in an antenna system? So what you want to do here is have some sort of impedance matching at the junction between the transmission line and the antenna. So B is the correct answer. If the antenna is correctly matched to a transmission line, the length of the transmission line will have no effect on the matching. So B is the correct answer. If you're in a matched system, the length is not important. Why is an antenna tuner external or internal frequently used with modern solid-state transceivers? So that's C. It enables transceivers to deliver the rated power to a mismatched antenna system. So C is the correct answer. So if a transmission line has a characteristic impedance of 50 ohms, feeds a folded dipole with a feeded input impedance close to 300 ohms, what impedance transformation ratio is needed to match the two units? So basically what you do here is you divide 300 by 50, gives you 6. So you look for an answer that has 6 in it. So you need a 6-to-1 a transformation ratio. And that concludes this section. So let me just stop the recording here.